In this lesson, we'll go through two examples on how to calculate different types of concentrations. In question number 1, we're asked, a solution is prepared by dissolving 17.2 grams of ethylene glycol, which has the chemical formula shown there, in 0.5 kilograms of water. The final volume of the solution is 515 milliliters. For this solution, we have to calculate the molarity, the molality, the percent by mass, mole fraction, and mole percent. Let's start with molarity. Molarity is a measure of the number of moles per liter. So let me go ahead and write that down. The molarity is a measure of moles per liter. Let's go ahead and use our periodic table to find out the molar mass of each individual atom. So for carbon, the molar mass is 12.01 grams per mole. And don't forget that there are 2 of them, so we'll multiply that number by 2. Hydrogen is 1.01 grams per mole, and there are 6 of those. And oxygen is 16.00 grams per mole, and we'll multiply that by 2. We have 12.01 times 2 plus 1.01 times 6 plus 16 times 2, and we end up with 62.08. So we have 62.08 as the molar mass of this molecule. What we can do next is use this ratio, this fraction, reciprocate it, and multiply it to the following number. Let me show you what happens when you do that. So I'm going to go ahead and reciprocate that, where I have 1 mole at the top and 62.08 grams at the bottom. I'll multiply this number by 17.2 grams. This unit and this unit will cancel out, leaving us with only moles. Since we want moles per liter, we will then divide this by 515 milliliters converted to liters. And we can easily convert this into liters by dividing it by 1,000, giving us 0.515 liters. So let's go ahead and find the answer to this first. We have 17.2 divided by 62.08. You should end up with this number. And then I'll divide that by 0.515. And we end up with 0.5379. And to 3 significant figures, this 7 will go up to 8. So we have 0.58. 0.538 moles per liter. To calculate the molality, we use the amount of ethylene glycol in moles from part A that we found and divide it by the mass of the water in kilograms, because molality is a measure of the amount of solute in moles per the amount of solvent, which we are told in kilograms. So molality is a measure of moles per mass of solvent. So I'm going to go ahead and calculate this again and use that for the top part. So we have 17.2 divided by 62.08. You should end up with a number that looks like this, and we'll divide this by the amount of kilograms, which is 0.500. 0.500, and we get 0.554 moles per kilogram. And for short, rather than writing moles per kilogram, you can simply write a small letter m, and rather than this, you can write a capital M. To find the percent by mass, we divide the mass of the solute by the mass of the solution. So the mass of the solute was 17.2 grams. Let's write that down. We have 17.2 grams. And the mass of the whole thing is 17.2 grams plus this mass. So let me show that. 17.2 grams. We need to convert this into grams as well. Plus 0.500 kilograms converted into grams using this conversion. 1 kilogram at the bottom and 1,000 grams at the top. Using our calculator, 17.2 divided by 17.2 plus 0.500 times 1,000 gives us this number times 100, because we are converting it into a percentage, 3.33 to three significant figures. So for C, it's 3.33%. I've made some more room for question D. This time we want the mole fraction. To calculate this number, first determine the amount of water in moles from the mass of water and its molar mass. So the molar mass of water, remember it's H2O, we have 2 times 1.01 plus 16.00. That should give us 18.02 grams per mole. We'll now reciprocate this and multiply it to the mass because we want the moles of water only. And we'll multiply this by the mass, which was 0.500 kilograms, converted into grams is 500. This cancels out with that. And using our calculator, 500 divided by 18.02 gives us 27.74. 27.74 moles. Once you've found the moles, you then divide the amount of ethylene glycol in moles from part A by the total number of moles. So using what we found in part A, we'll have to recalculate that. So we have 17.2 divided by 62.08, 27706 moles, divided by the same number plus this. Let's quickly use our calculator. That number on your screen divided by, again that number on your screen, plus 27.74, and we end up with 9.88 to three significant figures. We can say 9.89 times 10 to the power of negative 3. 9.89 times 10 to the power of negative 3. No units here because the mole units cancel out. And there should be a mole unit here that goes away, okay? Lastly, we have to find the mole percent. Multiplying this by 100 gives us 0.989%. That's the answer to question number 1. If you'd like to see the solution to question number 2, make sure you watch part 2 of this series. We'll see you soon.